Good morning, children. Today, let us start the chapter Pair of Linear Equations in Two Variables. In 9th standard, you have studied about linear equation in one variable. What is a linear equation in one variable? Consider an equation 2x plus 5 is equal to 0. Here, the equation 2x plus 5 has only one variable x and the degree of the variable x is 1. So, the equation 2x plus 5 is equal to 0 is called a linear equation in one variable. If an equation having one variable of degree 1 is called a linear equation in one variable. So, an equation having one variable of degree 1 is called a linear equation in one variable. Then the general form of a linear equation in one variable is ax plus b is equal to 0, where a is not equal to 0, a and b are real numbers. Next, linear equation in two variables. Consider the equation 3x minus y plus 2 is equal to 0 and x plus 4y minus 1 is equal to 0. Here, equations have the same variables x and y and the degree of the each variable is 1. So, these equations are called linear equations in two variables. So, an equation having two variables of degree 1 is called a linear equation in two variables. The general form of linear equation in two variables is ax plus by plus c is equal to 0, where a is not equal to 0 and b is not equal to 0. A, b and c are real numbers. So, an equation having only one variable of degree 1 is called linear equation in one variable. The general form of the linear equation in one variable is ax plus b is equal to 0, where a is not equal to 0, a and b are real numbers. Next, an equation having two variables of degree 1 is called a linear equation in two variables. The general form of a linear equation in two variables is ax plus by plus c is equal to 0, where a is not equal to 0 and b is not equal to 0. A, b, c are real numbers. Next is linear pair. Consider the two linear equations in two variables. Consider two linear equations in two variables 2x plus 3y minus 5 is equal to 0 and x minus 2y plus 3 is equal to 0. Here, the linear equation 2x plus 3y minus 5 is equal to 0 and x minus 2y plus 3 is equal to 0 are the two linear equations in the same two variables x and y. So, if we consider these two linear equations in two variables together, then they are said to form a linear pair. So, the two linear equations in the same two variables when considered together are said to form a linear pair or a system of linear equations. The general form of a linear pair is a1x plus b1y plus C1 is equal to 0 and A2x plus B2y plus C2 is equal to 0, where A1, A2, B1, B2 and C1, C2 are real numbers such that A1 square plus B1 square is not equal to 0 and A2 square plus B2 square is not equal to 0. Next, solution of a linear pair. Consider a linear pair. Consider a linear pair 2x plus 3y is equal to 16 and x minus 2y is equal to 1. Put x is equal to 5 and y is equal to 2. Then consider the LHS of the first equation. 2x plus 3y is equal to 2 into 5 plus 3 into 2. 2 5s are 10 and 3 2s are 6. 10 plus 6 is 16. So the 16 is the RHS. Next, consider the LHS of the second equation. X minus 2y. X is 5 minus 2 into 2. 5 minus 4. 5 minus 4 is equal to 1. 1 is the RHS of the second equation. So here the values of x and y satisfies both the linear equations in two variables. Therefore, x is equal to 5 and y is equal to 2 is a solution of the given linear pair. So, a pair of values of x and y satisfying each of the equations in a given linear pair is called a solution of the linear pair. Next, algebraic conditions for solving a linear pair. The first condition is if a1 by a2 is not equal to b1 by b2, then the system has a unique solution. If the system has a unique solution, then it is said to be consistent. Next, the second condition is if a1 by a2 is equal to b1 by b2 and b1 by b2 is equal to c1 by c2, then the system has infinite number of solutions. And if the system has infinite number of solutions, then it is said to be dependent consistent. Next, the third condition is if a1 by a2 is equal to b1 by b2 and b1 by b2 is not equal to c1 by c2, then the system has no solution. If the system has no solution, then it is said to be inconsistent. If a1 by a2 is not equal to b1 by b2, then the system has a unique solution and is said to be consistent. If a1 by a2 is equal to b1 by b2 is equal to c1 by c2, then the system has infinite number of solutions and is said to be dependent consistent. If a1 by a2 is equal to b1 by b2 and b1 by b2 is not equal to c1 by c2, then the system has no solution and is said to be inconsistent. See the figure. Here the lines L1 and L2 intersect at a point P. So if the graphs of the two linear equations intersect at a point, then the system has a unique solution. If the system has a unique solution, then it is said to be consistent. Now see the figure 2. Here the lines L1 and L2 coincide with each other. If the graphs of the two linear equations coincide with each other, then the system has an infinite number of solutions. If the system has an infinite number of solutions, then it is said to be dependent consistent. Now see the figure 3. Here the lines L1 and L2 are parallel to each other. If the graphs of the two linear equations are parallel, then the system has no solution and it is said to be inconsistent. So, if the graphs of the two linear equations intersect at a point, then the system has a unique solution. If the graphs of the two linear equations coincide with each other, then the system has a infinite number of solutions. And if the graphs of the two linear equations are parallel, then the system has no solution. Now, let us start that exercise 1. First problem. On comparing the ratios A1 by A2, B1 by B2 and C1 by C2, find out whether the following pairs of linear equations intersect at a point, are parallel, or coincident. The given linear pairs are 5x minus 4y plus 8 equals 0, 7x plus 6y minus 9 is equal to 0. Here A1 is 5, B1 is minus 4, C1 is 8 and A2 is 7, B2 is 6 and C2 is minus 9. Now find out the ratios of A1 by A2. A1 by A2 is equal to 5 by 7 and B1 by B2. B1 is minus 4 and B2 is 6. So minus 2 by 3. Next, find out C1 by C2. C1 is 8 and C2 is minus 9. Now see the ratios A1 by A2 and B1 by B2. Here A1 by A2 is 5 by 7, B1 by B2 is minus 2 by 3. Here so the A1 by A2 is not equal to B1 by B2. A1 by A2 is not equal to B1 by B2. If A1 by A2 is not equal to B1 by B2, then the system of equations has unique solutions. So, since the system of equations has unique solution, then the lines intersect at a point. Next question. Here A1 is 9, B1 is 3 and C1 is 12 and A2 is 18, B2 is 6 and C2 is 24. Now find out A1 by A2. A1 is 9, A2 is 18, 9 by 18 is 1 by 2. And next B1 by B2. B1 is 3 and B2 is 6. So 3 by 6 is equal to 1 by 2. And C1 by C2. C1 by C2. C1 is 12 and C2 is 24. So 12 by 24 is equal to 1 by 2. Here all the three ratios are equal. Here A1 by A2 is equal to B1 by B2 is equal to C1 by C2 is equal to half. Here all the ratios are equal. Therefore, the system of equations has infinite solutions. Therefore, the given lines coincide. The next third linear pair is 6x minus 3y plus 10 equals 0, 2x minus y plus 9 is equal to 0. Here A1 is 6 and A2 is 2. Find out the ratio A1 by A2. 6 by 2. 6 by 2 is 3. Next B1 by B2. B1 is minus 3. B2 is minus 1. Minus 3 by minus 1 is plus 3. And C1 by C2. C1 is 10 and C2 is 9. It is not divisible. Keep as it is. Now see the ratios. Here A1 by A2 is equal to B1 by B2. Both the ratios are same, that is equal to 3, and C1 by C2 is 10 by 9. So A1 by A2 is equal to B1 by B2, but B1 by B2 is not equal to C1 by C2. Since a1 by a2 is not equal to b1 by b2, therefore the system of equations has no solution. Therefore, the given lines are parallel. Next question. On comparing the ratios a1 by a2, b1 by b2 and c1 by c2, find out whether the following pairs of linear equations are consistent or inconsistent. The first linear pair is 3x plus 2y is equal to 5 and 2x minus 3y is equal to 7. Express this in standard form. 3x plus 2y minus 5 is equal to 0. 2x minus 3y minus 7 is equal to 0. Now find out the ratio of a1 by a2. a1 by a2. a1 is 3 and a2 is 2. Next, b1 by b2. b1 is 2 and b2 is minus 3. And c1 by c2. c1 is minus 5. c2 is minus 7. So 5 by 7. Here, say the ratio a1 by a2. a1 by a2 is 3 by 2 and b1 by b2 is minus 2 by 3. It means a1 by a2 is not equal to b1 by b2. Since a1 by a2 is not equal to b1 by b2, therefore the given pair of equations has a unique solution and it is consistent. The next linear pair is 5x minus 3y is equal to 11 and minus 10x plus 6y is equal to minus 22. Express in standard form. 5x minus 3y minus 11 is equal to 0 and minus 10x plus 6y plus 22 is equal to 0. Now find out the ratio of a1 by a2. a1 is 5 and a2 is minus 10. 5 by minus 10 is equal to minus 1 by 2. Next, b1 by b2. b1 is minus 3, b2 is 6. This is equal to minus 1 by 2. And c1 by c2. c1 by c2. c1 is minus 11 and c2 is 22. That is equal to minus 1 by 2. Now, all the three ratios here, a1 by a2 is equal to b1 by b2, b1 by b2 is equal to c1 by c2 is equal to minus 1 by 2. Here, since all the three ratios are equal, therefore the given pair of equations has infinitely many solutions, hence it is dependent consistent. Next, the third linear pair is 2x minus 3y is equal to 8 and 4x minus 6y is equal to 9. So, express in standard form. 2x minus 3y minus 8 is equal to 0 and 4x minus 6y minus 9 is equal to 0. Find out the ratio of a1 by a2. a1 is 2 and a2 is 4. 2 by 4 is equal to 1 by 2. Next, b1 by b2. b1 is minus 3 and b2 is minus 6. Minus 3 by minus 6 is 1 by 2. And find out c1 by c2. c1 is minus 8 and c2 is minus 9. Here, the a1 by b2 is equal to b1 by b2. a1 by a2 is equal to b1 by b2, but b1 by b2 is not equal to c1 by c2. Therefore, the given pair of equations has no solution, hence it is inconsistent. Next question. Find the values of k for which the system of equations x minus 2y is equal to 3, 3x plus ky is equal to 1 has a unique solution. Now, express the given linear pair in standard form. X minus 2y minus 3 is equal to 0 and 3x plus ky minus 1 is equal to 0. Find out the ratio of a1 by a2. a1 is 1 and a2 is 3 and find out the ratio of B1 by B2. B1 is minus 2 and B2 is K. So since the system has a unique solution, therefore the ratio A1 by A2 is not equal to B1 by B2. So A1 by A2 is 1 by 3 is not equal to minus 2 by K. Then K is not equal to minus 6. Since K is not equal to minus 6, therefore the given system of equations will have a unique solution for all real values of K other than minus 6. Next question. Find the value of K for which the given system of equations has infinitely many solutions. So Kx plus 3y is equal to K minus 3 and 12x plus Ky is equal to K. So write the given linear pair in standard form. Kx plus 3y minus of K minus 3 is equal to 0 and 12x plus Ky minus K is equal to 0. Since the equations has infinitely many solutions, therefore A1 by A2 is equal to B1 by B2 is equal to C1 by C2. Here A1 is K and A2 is 12 is equal to B1 is 3 and B2 is K is equal to C1 is minus of K minus 3 by C2 is minus K. Now equate the first and second ratios. K by 12 is equal to 3 by K and second and third ratio 3 by K is equal to minus get cancelled K minus 3 by K. Now take the cross multiplication. K into K is K square is equal to 36. So K is equal to plus or minus square root of 36. So K is equal to plus or minus 6. Here K into take cross multiplication. K into K minus 3 is equal to 3K. K square minus 3K minus take minus 3K to left hand side minus 3K is equal to 0. Next K square minus 6K is equal to 0. Take K common factor. K minus 6 is equal to 0. So K is equal to 0 or K minus 6 is equal to 0. Therefore, the given system of equations has infinitely many solutions when K is equal to 6. Next question. Find the values of A and B for which the system of linear equations has infinite number of solutions. So, express the given equations in the standard form. A plus B into Ax minus 2by minus 5a plus 2b plus 1 is equal to 0 and 3x minus y minus 14 is equal to 0. Since the given equations has infinite number of solutions, therefore a1 by a2 is equal to b1 by b2 is equal to c1 by c2. Here a1 is a plus b and a2 is 3 is equal to b1 is minus 2 and b2 is minus 1 is equal to c1 is minus of 5a plus 2b plus 1 and c2 is minus 14. Now equate the first and second ratio and second and third ratio. So a plus b by 3 is equal to 2 and 2 is equal to minus and minus get cancelled 5a plus 2b plus 1 by 14. Next, a plus b is equal to, take the cross multiplication, 6b. So a is equal to 6b minus b. So a is equal to 6b minus b is 5b. Next, here 5a plus 2b plus 1 is equal to 14 2s are 28b. Next, substitute 5b in place of a. 5 into 5b plus 2b plus 1 is equal to 28b. So 5 5s are 25b plus 2b plus 1 is equal to 28b. 25b plus 2b is 27b plus 1 is equal to 28b. Next, take 27b to RHS. 28b minus 27b is equal to 1. Therefore, 28b minus 27b is equal to b is equal to 1. Now, substitute b is equal to 1. Now, put b is equal to 1 in a is equal to 5b. So, a is equal to 5 into 1 is equal to 5. Therefore, a is equal to 5 and b is equal to 1.